Alright, today we are going to deal with graphing functions of all different varieties. We're going to start with this particular function, f of x equals x squared. Anytime you're going to graph a function when it's given to you in function form, you can graph it by making a table of values. And now in order to graph it, you should pick values for x and substitute them into the equation, figure out what the answer is, and that would be your y value, and then you plot the points. You continue to do that until you know beyond a shadow of doubt what the graph looks like. So at this point in time, pause the movie and graph this. Give you like 2 minutes to see if you can come up with something of what it's supposed to look like. So push pause now, please. Thank you. All right, welcome back. So here is what we have. If you choose 0 and substitute it in, you will get 0. If you choose 1 and substitute it in, 1 squared is 1. When you substitute 2 in, 2 squared is 4. When you substitute 3 in, 3 squared is 9. 4 is 16. 5 would be 25. 6 is 36, and so on and so forth. But you should try numbers on the other side of the y-axis as well, so that would be -1. And when you take a -1 and square it, you get 1. Hopefully you're not using your calculator to square any of these, but understand that when you put this into your calculator, -1 squared, if you type -1 and squared like this, your answer is going to become a -1, which is not correct because you are taking a -1 and squaring it, so you need to put it in parentheses. That is a common error that people make because they rely on their technology too much and do not use their brain to think. Please don't do that. So now, if you substitute a -2 in, a -2 squared is 4. A -3 squared is 9, and a -4 squared is 16. So if we plot these points, we have 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, -1, 1, -2, 4, -3, 9, -4, 16, and so on and so forth. And we get this fine looking thing that is called a parabola. Now, when you look at this parabola, it's a U-shaped kind of thing. It continues on forever and ever in both directions. The domain of this particular function would be all real numbers. The range would be all real numbers greater than or equal to 0. All right, so now that we know that, let's look at this one. Again, take a moment to graph this. Pause the video and see what you come up with. You can do that now. Okay, so here we go. Again, if you substitute a 0 into this, 0 minus 3 is a -3, and a -3 squared is 9. If you put a positive 1 in, 1 minus 3 is a -2, and a -2 squared is 4. If you substitute a positive 2 in, 2 minus 3 is a -1, and a -1 squared is 1. A 3 would get you 3 minus 3, which is 0, and 0 squared is 0. A 4 gets you 4 minus 3, and that's 1, and 1 squared is 1. 5 is 2 squared, which is 4. 6 is 3 squared, which is 9. If you try a -1 for a number, a -1 minus 3 is a -4, and that is 16. And now we're off the chart, so I think we have enough stuff here to sketch our graph. We have 0, 9, 1, 4, 2, 1, 3, 0, 4, 1, 5, 4, and 6, 9. And now our parabola looks like this. Going to the next one. f of x equals x plus 2. Pause the video, sketch the graph. Welcome back, and here we go. Substitute 0 in. 0 plus 2 is 2, and 2 squared is 4. A 1 would be 3 squared is 9. A 2 would be 4 squared, which is 16. A 3 would be 5 squared and 25, and we're off the chart. So we better go the other direction. A negative 1 would be 1 squared, which is 1. A negative 2 would be 0 squared, which is 0. A negative 3 would be a negative 1 squared, which is 1. A negative 4 is a negative 2 squared, which is 4. A negative 5 is negative 3 squared, which is 9. And a negative 6 is going to be 16 because that's a negative 4 squared. Don't need to go any further because we're off the chart again. So 0, 4, 1, 9, 2, 16, negative 1, 1, negative 2, 0, negative 3, 1, negative 4, 4, negative 5, 9. And now we have our graph drawn. And it looks like that. Now, went a little too far there, so let's just get rid of this stuff. You've got to be kidding me. All right, let's try that again. Thank you. And there. Now, just for a moment, look at the blue one that we started with, and it was that function. Look at the green function and look what's here, and look how it is graphed. Look at the red one, look at the equation or the function, and look how it's graphed. If you notice something, don't say it and ruin the surprise for those who haven't figured it out yet. If you haven't figured it out yet, well, we're going to do a few more to maybe help you see things. Pause the video again, take 2 minutes, graph that one. And here's what you will have. 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. A negative 1 squared is 1 plus 1 is 2. A negative 2 squared is going to be 5. And a negative 3 squared is going to be 10. And so on and so forth. And so 0, 1, 1, 2, 2, 5, 3, 10. Negative 1, 2, negative 2, 5, whoops, and negative 3, 10. And now our parabola looks like this. All right, and now one more. And maybe if you've been seeing things, you can sketch this graph without even having to make your little chart. Take 2 minutes again, pause the video. Okay, here we go. X, Y, 0 squared is 0, so that's a negative 3. 1 squared is 1, and that's a negative 2. 2 squared is 4, and 4 minus 3 is 1. 3 squared is 9, and 9 minus 3 is 6. 4 squared is 16, and 16 minus 3 is 13. Let's go the other way, and a negative 1 squared is 1, so that's a negative 2. A negative 2 squared is 4, minus 3 is 1. A negative 3 squared minus 3 is 6, and so on and so forth. And 0, negative 3 is right there. 1, negative 2 is right there. 2, 1 is right there. 3, 6 is right there. And same on the other side. And so now our graph looks like so. And so we probably should just get rid of that stuff. And we will probably need to get rid of that stuff. Okay. Now look at the yellow one and the turquoise one, and look at their graphs. And where are they located in comparison to our main function, the blue one? Are you seeing something now? I hope so. Now let's get into this one. See if you can apply all of this and what you see here to this purple one. I'm not going to take any time for this one as far as where you need to graph it. I'm just going to draw it for you, and so just follow along and see if you can see what's happening. There is one of the points. And then that point right there, and that point right there, and then this one, and that one, and that one, and that one, and our parabola will look like that. And our final one of the day for this part of our class is this one here. And if we graph that, it is going to be, there's a point, and then from there we're going to go there and there, and there and there, and there and there, and this is our graph. And so now I hope you can see that with this function, when you have something inside the parentheses that is impacting the x value, look at the red one, and where is it compared to the blue? To the right 3 places. Look at the purple one. It is to the left 5 places as far as the x value is concerned. With this one, the black one, it is to the right 2, and the green one is to the left 2. So when it is something that is impacting the x, meaning it's with the x, the opposite thing is happening to your graph. So it is shifted the opposite way. Left 5, right 2, right 3, and up 2. Then, if you look at the other parts, this and that and that and that, it is not with the x. So it doesn't impact the x part of it. It impacts the y part. And if you look at the yellow one, it is up 1, and that is plus 1. If you look at the purple one, it is plus 2, and this one is up 2. If you look at the black one, it is down 4, and if you look at the turquoise one, it is down 3. That rule, or those 2 rules, apply to every single function you could ever draw in your entire existence. If you have a function and you're given something like this and said graph it, you know that whatever this function is, if you see this, without these things, if you want to graph that function, you know that all you have to do is take your original and move every point to the right 3 places. So, in general, if you have a function f of x, and you have something f of x minus h plus k, the h value tells you to move a function left or right, the opposite of the sign that is in here. If it is minus h, then you move it to the right. If it is plus h, you move it to the left, because it goes the opposite, because it's impacting the x. The k value is going to move a function up or down in the same direction. So a plus k will move your graph up, and a minus k will move your graph down. Now then, if we're going to graph these things, here is f of x. It is this particular function and it is graphed like that. So our first one here in blue says f of x plus 2 minus 3. The plus 2 is going to move our graph which direction? 2 to the left. And 3 down. So we are going to take our point, go 2 to the left and 3 down, and there's going to be a coordinate, and there is our graph. The shape does not change, it just gets moved. Looking at the next one, we have to go 5 to the right and 6 down. So if we start at this point and go 5 to the right and 6 down, we would be right there. And then all the other points have to do the same exact thing. And it should appear, but it's not. So it will go like so. To right there. Still the same shape. Our red one here goes to the left 3 and up 4. So that would be left 3 and up 4. And there's our graph. And finally, the black one says to the right 3 and up 5. So all points on our green one are going to go to the right 3 and up 5. That point right 3 and up 5, and our graph would look like so. And that is what you're going to do in today's assignment. And there it is. Enjoy, and I will see you tomorrow.